All right, welcome to the first notes of Unit 3. All right, so Unit 3 is basically going to be the regression unit. Now, there's going to be some stuff that we talk about before we get to regression itself, but that's the sort of main topic that we're going to hit on in this unit. All right, so we're going to start by looking at scatter plots and correlations. Then we're going to move on to least squares regression. We're going to see how those equations are actually calculated, what goes into them. So it'll be more than just like put it into the calculator and there's the regression equation. We'll kind of learn how it actually comes about and where the calculator is getting those values and numbers from. Okay. All right, so first things first, we usually start with graphical representations. All right, we've done that in pretty much every unit we've gone through. We start with, all right, how do you graphically represent what's going on here? And when we're dealing with this unit, our primary tool is going to be the scatter plot. All right, so a scatter plot is a graphical display that shows the relationship between two quantitative variables. All right, so again, we have our different tools for different data. And a lot of times that depends. Is it categorical? Is it quantitative? Do you have one variable? Do you have two variables? All right, so the scatter plot is when you have two variables and they are both quantitative. All right, so when we're describing bivariant data, all right, there's a couple of things that we're usually going to look for. All right, we're going to plot the data and add a numerical summary. And that numerical summary is usually going to take the form of the correlation. All right, we're going to look for the overall pattern. So these points that we've plotted, do they follow a linear pattern? Do they follow a curved pattern? Is it exponential? Is it this? Is it that? But what sort of pattern does it follow? And then we're going to use a simplified model to describe the overall pattern. And that simplified model is what we usually call the regression equation. All right. And that's basically what a regression equation is we look at old data. We try to discern the pattern in that data, how one variable moves with another variable. And then presumably, we hope that that pattern stays the same, and we can use our equation to make predictions and educated decisions about the future. Right, so that's kind of the big idea there, and that's why regression is so useful, and it gets used in all sorts of fields these days. Regression is a tool that you really can't get away from if you do anything analytical in the modern world, because we just use it all the time to sort of make predictions, evaluate scenarios, try to like discern insights about which factors are more influential. So it has all sorts of applications that it can be used in. And we're going to just scratch the surface of what's possible with regression. All right. So you have, when you're making a scatter plot, the explanatory and the response variables. The explanatory is also sometimes referred to as the independent. And hopefully this is somewhat familiar from your science classes. And the response is sometimes referred to as the dependent. So again, hopefully terms that you've seen before, if not in math, at least in science. The explanatory, which is your X variable, explains the response variable, which is your Y. All right, so just keeping those straight. You've got independent, explanatory, X all go together, response, dependent, Y all go together. So Any of those could be used interchangeably, and you've got to make sure that you're comfortable saying, okay, he's talking about this one, or okay, he's talking about that one, and be able to go from there. All right, for each of the following studies, decide which variable is most likely to be the explanatory and which is the response variable. So again, take a moment, do these in your head real quick, and then I'll just run through them one by one. All right, so first one, study time versus exam grade. All right, study time is more likely to be your explanatory. Whoops, let me move this so you can actually see it. All right, study time versus exam grade. Study time is probably going to be your X. Exam grade is going to be your Y. The amount that you study is probably going to explain how well you do on the exam. All right, height versus weight. Again, on this one, I'm going to say that height is probably the explanatory, and weight is probably the response variable. So the taller you are, the more you are likely to weigh, right? You can weigh a lot and not necessarily be very tall, but as you get taller, it's kind of unavoidable that your weight is going to go up. So height helps explain weight. And then rainfall and amount of crops harvested. Again, I'm just going to say the rainfall helps determine the amount of crops. If you have too little rainfall, you might not have a lot of crops. If you have just the right amount of rainfall, you might have a lot of crops. And if you have too much rainfall, you might actually end up with less crops. So this might not be a straight linear relationship here. There might be a curve to this relationship because there's sort of a sweet spot. And too little is bad and too much is bad. Now, it was just coincidence that the X always ended up first here. I could give them to you in any order, and you still have to be able to determine which one's the explanatory, which one's the response. But usually, kids don't have a problem with that. It's usually pretty straightforward. All right. So how to make a scatter plot. First, you need to start by deciding which variable should go on each axis. So remember, we just said that the X variable should be your explanatory and the Y variable should be your response. Then you need to label and scale your axis. Then you're just going to plot the individual data values. So here I have two variables. They're both quantitative. One is body weight and one is backpack weight. So this is dealing with like backpacking out in the mountains and how much weight you're going to carry on your back. So generally, the larger you are or the bigger you are, the more you can carry on your back. And the smaller you are, the less you can carry because it's like a greater percentage of your weight. So this is going to be our X because how big you are determines how much you are likely to be willing to carry on your back, right? If you only weigh 100 pounds, you're not going to want to carry 70 pounds on your back. But if you weigh 200 pounds, 70 pounds might not feel as bad. All right, so we're going to label our axes. So this one will be our body weight. This one will be our backpack weight. And then we just want to make sure that we kind of scale these out. So I'm just going to go and say, all right, we'll put this one at 100, call that 120, 140, 160, 180, and then 200. And on this side, let's see, our smallest value is 24. So we'll start this at 20. Maybe I'll go up by twos. So that's 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. All right, so I've got my x-axis, I've got my y-axis, and then it's just a matter of going through and plotting those individual points. So 120 is at 26, So 2, 4, 6 right there. 187, which we'll say is about right there, is at 30 pounds. So maybe right there. 109 is at 26, 22, 24, 26. 103 is at 24, 22, 24. 131, which should be over here, is at 29. 165, which is probably right here, is at 35. 158, right here probably, is like 31. And then 116, which is again back down here, is at 28. So it'll be right there. All right. So there we kind of have our scatter plot. All right. Now, there's going to be things that we can talk about and describe about the scatter plot. All right. The same way we've described distributions before and said, oh, the shape is this, the center is this, the spread is this. We're also going to make similar descriptions about our scatter plots. So what I'm going to do is I'm going to go through these one by one, and then we'll come back and describe this chart to see what we actually have here. So the first thing that we can describe is the direction. All right. So the direction is either going to be described as a positive association or a negative association. So a positive association is when, as the explanatory variable, which is your x, increases, the response variable which is your y, also increases. Now, I don't want to make this sound any more complicated than it is. It's basically just when you have a positive slope. All right, so if you think of the points as like a line, a positive association is basically when you've got a line that has a positive slope. So let's not make it any more complicated than it has to be. And then the negative association is the reverse. So as the explanatory variable x increases, the response variable, which is your y, decreases. And again, let's not make this any more complicated than if you think of it as a line, it's basically a line with a negative slope. All right, so pretty easy to kind of envision that. But just to be sure, let's go to this page, and it says sketch a scatter plot with each association. So a positive association is going to be when the scatter plot is going up and to the right, as if you've got a positive line. A negative association is going to be when it's going down and to the right, just like it would be with a negative sloped line. And no association is when you're going to just basically have sort of this cloud of points where there's no real direction at all to the points and what's going on there. All right. All right. We're also going to be talking about the form of our scatter plot. So that's referring to, is it linear? Is it curved? Is it exponential? Like what sort of direction are these points going in? Like if you were to draw a line through them, how would that line sort of look? All right. But that's what we're going to be referring to when we talk about the form. The strength is going to be the strength of a relationship is determined by how close the points in the scatter plot lie to a simple form such as a line. All right, so we're going to have ways of measuring strength, but for right now, we'll just say like, oh, it's like very strong or mild or weak, but we will eventually attach a numerical value to that. And then last but not least, an outlier. Now, this is going to be a little different than our outliers from the 1.5 times the IQR. All right, so in this case, when we're analyzing a scatter plot, an outlier is a point on the scatter plot that goes against the overall pattern of the data. So, for example, if most of your data was here following this pattern, and then you had one point down here, this would be an outlier because it's going against sort of the overall pattern of the data. All right, so keeping all of this in mind, let's go back to our graph over here. All right, so if we were going to describe this graph, we would start by saying, okay, there appears to be a positive association because our points are going up and to the right fairly consistently. So we have a positive association. All right. There doesn't appear to be any really curve to our data. So we can say the form is linear. So it has a linear form. All right. Now, it's not, these points are not in a straight line, so it's not like a pure linear relationship, but most of the points follow a pretty consistent line. We've got this one over here that's a little off the beaten path, but most of these, if we were going to kind of draw in a line, all right, most of those are pretty close to that line. So we can say that the relationship or the association or the strength, we'll say the relationship is fairly strong. And then we might finish that off with, one outlier at, what point was that? The 187 at 187, comma 30. So that's somebody that, based on their size, we would have expected them to be carrying a much heavier pack, but for whatever reason, their pack was only sort of 30 pounds there. All right. So it's very similar to what we were doing earlier when we were describing a histogram, right? The only difference is the histogram is for one quantitative variable, and the scatter plot is for two quantitative variables. But if I ask you to describe a scatter plot, this is the sort of stuff that I'm looking for. I'm looking for, is the association positive or negative? What is the general form? And you can say things like linear, curved, exponential, things like that. And then comment how strong that relationship is. Like, are they following like a pretty clear pattern? Or, is it more of just like a general direction? And then finally, commenting on any potential outliers, points that deviate from that pathway. All right. So this is the introduction. Where we go from here is we're going to take a look at some of the numerical values we can calculate with this data. So we're going to look at things like correlations and eventually the regression equation and see where all of those come from. So, I know that you've seen and heard of all of these things before, but we're actually going to see how they're calculated and what the implications of those calculations are, as opposed to just sort of blindly putting the numbers into your calculator and reading off the number. All right, so that's where we're going with this, but this is kind of just like a brief introduction to get the ball rolling. All right, hope this was helpful. Have a great day, and I will see you when I see you.